And soon we'll have, I think we're merging, in my opinion, we are merging with machines. I mean, you see all these dystopian scenarios today. They all, what they all have in, they're all rather, most of them are rather silly. What they all have in common is that machines are evolving, but we're evolving too at a rate faster than the Darwinian rate of evolution, which is say on the order of 100,000 to 50,000 years to move from Homo erectus to Homo sapien. We're moving faster than that. And we're eventually going to move towards having more and more chips in our head.
Because that's intellectual evolution you're talking about here, isn't it? It's not a physical evolution.
Oh, physical also, absolutely. Uh, uh, with more mechanical components in us, we will be changing. We will be able to do things that previous generations weren't able to do. I mean, there are parts of all parts of the brain have are for a certain purpose, and so you can replace them with a chip with an algorithm on it, and soon you can replace the whole thing with chips, and lifetimes will increase, and you can even talk about uploading your mind to a machine up in the cloud.
Arthur I. Miller is Professor Emeritus of the History and Philosophy of Science at University College London. He's trained as a theoretical physicist, and his real passion has always been creativity, what it is and how it works. He's the author of many critically acclaimed books, including Einstein, Picasso, Space-Time and the Beauty That Causes Havoc, nominated for the Pulitzer Prize, Empire of the Stars, Friendship, Obsession and Betrayal in the Quest for Black Holes, shortlisted for the Aventis Prize. His most recent book, The Artist in the Machine, The World of AI-Powered Creativity, explores AI and creativity in art, literature and music. And he writes for The Guardian, The New York Times, Scientific American, Wired and Nautilus. His new play, Synchronicity, recreates the intriguing encounters between the analyst Carl Jung and the brilliant but troubled physicist Wolfgang Pauli. Readings of it played to sell-out audiences in New York in 2023, and it was performed to critical acclaim at the White Bear Theatre, London, in November 2024. So, Professor Miller, thank you indeed for joining me today.
Well, thank you, Philip, for inviting me.
Tell me, you began your career as a theoretical physicist. Can you tell us what prompted you in that? What was the area of physics you were interested in? And why did it extend out into wider fields of art and the intersection between art and science?
Right. Well, let me begin at the beginning. In high school, I had a wide spectrum of interests: science, military science, art, philosophy, history, and photography as well. At the time I grew up in the Bronx, if you were smart or thought you were smart, you went into physics, which is what I did, even though my passion was in creativity. And so to turn back the clock, I frequented the public library in my neighborhood, which was a magisterial building of containing many books and also lots of 33 to 3rd RPMs, now known today as vinyls. And I still remember the day when I was sitting at a table reading a book, and it happened to be next to the collection of vinyls, which were stocked on end like books. And I looked up, and there was this amazing picture, a pencil sketch of a man deep in thought. So I, being a budding artist, I did like artists are supposed to do. You copy from works that you like. And so I took that sleeve home and copied from it. And I realized there was a record inside. So I decided to play it just to see what it was. Didn't have the slightest idea what to expect. I couldn't pronounce the name of the composer either. And it turned out to be Tchaikovsky's Sixth Symphony. And it was just blew my mind. I ran back to the library, borrowed more Tchaikovsky, and then worked my way back through the others. But what immediately struck me was, how did these people create those powerful melodies? So I was hooked into creativity. Well, I went on with physics, and to move ahead in time, I decided after writing physics papers, and the area of physics I was interested in was theoretical elementary particle physics, like quantum field theory. That was all well and good, but that was not where my passion was. And so I decided to switch fields to history and philosophy of physics. And I began to read the original German language papers in relativity theory and quantum theory, papers by Einstein, Niels Bohr, Werner Heisenberg. And what immediately struck me was the emphasis that these people put on visual imagery. And so I decided to look into this deeper, and I moved into the field of cognitive science and to explore how the brain formulates images and then manipulates them. And this also brought me back into contact with computers. I had used them on my PhD thesis as number crunchers, but now there was a so-called mind-computer metaphor, where brain-computer metaphor, which let's leave the mind out of this, that the brain acts as if it is a digital computer. The payoff years later would come in the opposite direction, but at that time, is the brain acting as a digital computer? And what also struck me is the way these great scientists used the way these great scientists. You edit this, right?
Sorry, yeah.
Yeah, okay. The way these great scientists use terms like um, beauty and symmetry, just like it's used in art. And so I thought to myself, is there a connection between art and science? And this is a long time ago. This was in the 1980s, when the field of art and science was just a beginning field. Now it's everywhere. Everyone is an artist and scientist. But at that time, very, very few. And
Yeah, I mean, like you, I started with it as a theoretical physicist, but like, I've always been puzzled about this connection between science and art in this sense that whenever you had a competing theory, one theory rather than another theory, each could be the most likely, whether it's like a Copernican view of the universe or whether it's Ptolemaic view of the universe, the one which is said to be the true one is the one which is the most beautiful or
right.
the most simple, as if art itself now becomes the touchstone of the truth of the theory. Does that make sense?
Well, not art itself, concepts of art. And
Concepts
just
of
let me continue along this for a moment,
Yes,
because
sorry, no, I
it
interrupted
impinges
you.
on what you have to say. So I looked into history and philosophy of physics in order to study how the great scientists discover their theories, and then cognitive science, and then art science. And then I realized, well, why not look into art history as well? And so I hung out in art history departments too. Uh, Now, a logical extension of all of this was to look into computer science and look into what computers have to say about creativity and about art and science. So I hung out in computer science departments as well. Now, here's where they all touch. This approach convinced me that interdisciplinarity was the way to look at frontier problems. And interdisciplinarity is a tricky thing because it's sometimes confused with multidisciplinarity. And they're very different. Multidisciplinarity is like a fruit salad. No matter how you mix it up, you can still tell a grapefruit from a watermelon slice. But interdisciplinarity is like a smoothie. It's all worked into one. And there are some people more and more are working in a truly interdisciplinary situation. But universities are not set up for that. Universities are set up really for a silo kind of situation where you work in a particular field, and that's where you get paid in your department and so on. So it's difficult. It's almost as if you have to be an emeritus professor to do it, or be in some sort of unique situation. And here is where concepts of art can make a difference between theories. Excuse me, I'm coming out with a cold. For example, in elementary particle theories today, like string theory, there are they're so esoteric, so to speak, that that they don't point to any experimental results which can confirm them. And so what you look for is a way to distinguish between theories is whether they are aesthetic. And here the term aesthetic, of course, is a loaded term, but in science, there are definitions of what is aesthetic. A mathematical equation, a mathematical equation is beautiful if upon reflecting it in various directions, it maintains its form. So it's form invariant. That's a beautiful equation. Aesthetics in art doesn't have that means of definition. It's in the eye of the beholder, so to speak. Physical theories, to some extent, that's true also. At the beginning of, I mean, aesthetics really came full blown into science with Einstein's 1905 relativity theory, where he looked for the most beautiful way, most aesthetic way to represent nature, which he considered as beyond perceptions to be a beautiful setup. how can physics do that? And similarly, Picasso also looked towards aesthetics in formulating cubism.
Let me ask you this then. So is beauty really the test of truth in physical theory? You say that, you know, this theory, Einstein's theory, is a more beautiful theory than maybe previous ones, but why should beauty be the criterion by which we judge things in science?
Well, that's a good question. It seems that the universe is at bottom a beautiful setup. And so in order to reflect that, you need, in quotes, beautiful theories. And yet beauty in mathematics and physics you can define it. In art, it's difficult to define it. In art, there are various aesthetics. But Picasso was an aesthetic of cubism, and so on up to today, where one has conceptual art, which is rather stretching a point. I mean, conceptual art is the concepts that count, not the art. So you have a banana taped to a wall wins prizes.
Yeah, yeah. Yes, we can no doubt discuss the merits of that in some way. But does that mean that when you say you can measure beauty in physics, how do you do that? What's the approach that's taken to determine what's beauty from physical terms?
Well, equations that maintain their form when you change the variables in it, such as you reverse the direction of x, y, and z axes, and the equation maintains its form. It's said to be a beautiful equation. When you reverse left and right, if an equation maintains its form, it's said to be a beautiful equation. But the asymmetry also matters. And in this case, it turns out that switching left and right isn't always the case. That is to say, one can violate what's called left-to-right symmetry or parity symmetry. So asymmetry is important in physics as well. Feynman made a very interesting comment at one time when in 1958, he and Gell-Mann proposed a theory of beta decay. Beta decay is a radioactive process. And they devised a very interesting theory. And they proposed a critical experiment. If this experiment turns out to be okay, then the theory is fine. If not, then the theory is invalid. The experiment turned out not okay, turned out to invalidate the theory. And there's a classic reminiscence here where at the meeting where these experimental results were discussed, Feynman and Gell-Mann stood up and said almost as one person, the experiment's wrong. The theory
not that the facts are wrong, but the experiment is wrong.
Yeah, as Feynman put it, the theory is gleaming. It's goddamn beautiful. And the experiment was redone, and sure enough, it was wrong. Now that of course raises all sorts of one might say almost a can of worms, because if a lesser person had proposed that theory and the experiment ruled against it, would the experiment have been done over? These experiments are very difficult to do, but at any rate, it was done again, and there were similar experiments done which also confirmed their theory of beta decay. So everything was okay. Einstein did something similar. In 1905, I wrote a book. My first full-scale book was an exegesis of Einstein's 1905 paper. Something like 400 pages of equations and footnotes, and was reviewed in the New York Times also. But at any rate, in that paper, Einstein made several mistakes, and one of the mistakes led him to led him to the fact that one of his equations did not square with recent experimental data. And even after correcting that equation in a later paper, it still ran against the golden experiment, the golden elementary particle physics experiment of its day. Einstein said the experiment is wrong, and it turned out to be wrong. So there are several instances along these lines where some physicists have this sixth sense that their theory is correct and experiment is wrong. Now, to redo experiments now with CERN, for example, is nigh on to impossible because they're just much too expensive. And so what is done is that they're redone in simulation on a computer.
Well, how can we have confidence in them? And if that's the case, it's
Oh yes, yeah,
yeah,
absolutely.
yeah. So I mean, when it comes to laws of science, and we've been speaking about really fundamental laws, things that Einstein and his relativity papers of 1905 and so on, does scientific laws, such as produced by human brains, does it genuinely reflect reality?
Yeah, I
Or is
believe.
it really an approximation to reality, and we never get to what
Oh well,
reality is?
that's a big point. I
Big
believe it reflects a reality beyond appearances. I believe that there is an objective reality. That truth is not relative. Now, so you have an equation, you have a scientific theory. The point is when you do experiments, experiments have error bars, and but the scientific theory is mathematics. There are no error bars when you deduce certain results and so on. So you have to bear in mind that that your data to some extent is contingent. But so many experiments are done, and if these experiments all converge to what is predicted, then it's fine. I mean, even using something like F equals ma, Newton's law of motion, is an approximate thing. I mean, when you take a stone and drop it from say 6 feet above the ground, you can calculate from Newton's second law how long it will take the stone to reach the ground. But there are lots of assumptions there. One of the assumptions is that you're in a system in which all external forces cancel out, but that's not the case. You know, you can what's called you can close your system and get away with murder, so to speak. But the Earth is moving around the sun, things are rotating, so you're not in a system in a system called an inertial reference system, where all forces cancel out. We can do that it works out on the planet Earth. Okay, so we can get away with murder in that sense. So whereas the laws of physics are exact, experiments are inexact.
There are problems with even simple equations like F equals ma. I know that Ernst Mach was quite a critic
That's
of
right.
Newton and his formula of force, and said that it was a very circular kind of a formula, and that force itself didn't have much of a meaning except through the equation, and really you shouldn't talk about forces at all. But only mass times acceleration.
That's right. You go around circling. Various philosopher scientists at that time looked into the concept of what force is, and most of their definitions were circular. Were circular, and circular in a real punning sense too, because what Mach was doubted was these extra forces that emerge in rotating reference systems that seem to be strangers to Newton's law of motion, and that was straightened out by Einstein in a general relativity theory when he assumed that these forces are different source of gravity.
Yeah.
Uh,
Which shows some kind of progress, which is great. You say that you believe there is a reality at the bottom of things, and that there is an absolute truth. But these days, in this particular society, we live in a world where most young people, from what I saw with Gen Z or Gen Z,
I know.
they don't have such a confidence in absolute truth at all. Everything is much more relative and society seems to be moving in that kind of way. And
Well, what one has there is a growing disrespect for intellectualism, a growing disrespect for science as well. I mean, in the U.S., Trump just nominated for his Secretary of Health, Robert F. Kennedy Jr., who doesn't know anything about science, and he is in fact moving towards convincing the Federal Drug Administration to withdraw polio vaccines from its prescribed medicines. And so one has it's a real problem. I think if these people knew more science, it would things would be different.
is science under threat today?
Oh, very much so. Yeah, very much so.
And I mean, things that I've noticed just over my short lifetime, there seems to be a growing idea of groupthink. A lot of people seem to think in terms of group thoughts rather than individual thoughts, and there's a lot of intolerance also, I think. Whereas it seems to me that's quite anathema to science, which has an open mind to any possibilities and will test everything that comes its way. In fact, you could say society has got two different models of science, which it's competing against each other. There's consensus science, where, trust the science, believe the science, don't question the science. And then there's a more scientific, contentious idea of science, where every idea must be contestable. Every idea must be tested and checked and validated. And if
Conjecture,
not, just
refutation.
thrown
That's right.
away.
That's right. Yeah, yeah.
How do we resolve that particular conflict in society where we're told just to shut up and trust the science? Is that a
Well, you have to do that, and this goes back to maybe you remember this in the 1990s, is the so-called science wars, where there was a case in which there was there was a theory in elementary particle physics, which was tested at CERN, and no, sorry, there was work done in a particular area of particle physics, and this was a massive experiment. I mean, there were over 300 people in on it.
what was this about? What were they testing? Can we be specific?
So-called neutral current theory.
Neutral current theory. Okay.
And certain data were discarded as being, as not being accurate enough. We don't need it. And then a more refined version of this neutral current theory came along, and this data turned out to be important and was used to confirm the more improved version. And so the so-called people against science in the science war situation said, look here, what we have is science done by committee. One committee says the state is no good, another committee says it's good. So then they also looked at astronomical data, and these people, I assure you, they didn't know any science whatsoever. They said, look here, we pay all this money for these giant space telescopes, and these images, we don't see these things. You don't put your eye to the telescope and see it. They're pixelated images, and the pixels are put together by algorithms. And so, how are we supposed to believe the images? Maybe they're just fictitious. And this was rife, and it's becoming the case now too. There's a disrespect for experts, and all sorts of things emerge when you lose respect for intellectuals. I mean, look what happened in the 1930s in Germany. That's not so far-fetched.
Yes, I remember that at that time, and this is a nice story about Einstein, where I think Einstein was told that 1930s Germany government had got together 100 scientists who had all put their name to a piece of paper saying that Einstein's theory was wrong. And Einstein's reply was, well, if it was wrong, it would only take one scientist to be able to point it out.
Right. Yeah.
Which is a very nice point of view that, yes, it
Right.
depends upon falsification, doesn't it, upon whether it can be disproved. But it seems to me that we suddenly have a problem today with science, and it's one of those problems which we have a society which either doesn't trust science or moves along parallel tram lines so that the scientific method of testing everything is often not used. If it's a consensus, it's considered to be truth. And that's, of course, what was swept away by people like Galileo back in the days of just before Newton.
Yeah, well, I mean, you have the Enlightenment program under attack today. I think we could look back to where this all began, so to speak, in 1687 when Newton's Principia was published. And then one had this bifurcation between art and science, where science is the real thing. That's the key to truth, where art is just frivolous. And then over the years, they came back together again gradually. And I think in my opinion, they came back together again with force at the beginning of the 20th century with Einstein's relativity theory and Picasso's cubism. Because you have a case here where Einstein thought like an artist and Picasso thought like a scientist. And that's the way and at that nascent moment of creativity, boundaries dissolve between art and science.
That was a quotation I was going to quote to you from the book Insights of Genius, where you say that the boundaries between art and science dissolve at the point of creativity, which I thought was an excellent way of putting it, that creativity brings those two things together, because both science and art fundamentally require creativity at their heart, because if they don't have them, you can't create new theories and you can't create new art either.
That's right.
It's kind of the thing which unites them together. So can I ask this about it then? So is there a truth which science can lead us towards and another truth which art leads us towards? And are those truths the same, or are they different and complementary? I mean, how does the interface between those two work?
Well, to me, art and science are merging. Okay, so there will be only one subject you can call it art sci. And particularly so in the age of AI, when you have the new artist the AI artist who works with code, and the whole texture of what is art is changing to the extent that you have in the age of generative AI, when you put a prompt into a machine and the machine produces text, audio, or image. So now you have the artist is somebody who makes up the prompt. The machine produces the image. It will come to a point where the machine can assess its work, and when the machine thinks that's not very good, it will turn back to the human prompter for another prompt. And so you have each one bootstrapping the other's creativity.
But does that not reduce human creativity to a level of being merely a prompt? And are we not devaluing human input at this point? I mean, one of the complex
We're actually we're enhancing human input. We have machine and human, each one bootstrapping the other's creativity, with all the inherent ethical problems involved. But no, it's not downgrading human creativity whatsoever. In fact, we will become more creative. And we are becoming more creative now. Coders, for example, who use GPT-4 are much more efficient than coders who do not. And that's going across similarly across all walks of life, across all industries. I mean, no one is safe.
What do you make of Elon Musk's comment? Because he put out warnings about AI. And one of the things which he said is that AI the revolution which AI is producing is not understood, he claims, by human beings and by society at the present time. Because what AI will do, as far as he's concerned, is that it will eliminate all jobs, all human jobs in the future will be gone. Not just the ones that the Industrial Revolution may have got rid of, or even more complex, but every single job which a human being can do will be eliminated. It will not be necessary.
That may well be the case, but what is a human being will change.
That's the point. Well, what's the point of having a human being?
Very rapidly, yeah. That'll change very rapidly. Uh, to me, AI is the greatest intellectual adventure in the history of this planet. I mean, with other inventions like the wheel, the steam engine, the electrical dynamo, you knew where they were going to lead. You had some idea where they were going to go. We have no idea where AI is going to lead us, and that's the whole advent. It will change everything.
Do you think that AI has the capability? Because at the moment it's just what's called a large language model, which means that it can extract information from
Oh, it's more than that.
what's out there and
It's
put
much
it
more than
together
that.
in interesting ways. But do you think that, for example, you will ever have an AI system which will be truly creative in the sense that, for example, that Einstein was truly creative to create the special and general theories of relativity? Can you ever get a machine which will create a theory which will, say, supersede Einstein, maybe a unified field theory which will bring together quantum
Yes,
mechanics and
yes. Why
gravity?
not? I mean, these are still early days. I mean, I
Yeah.
always answer people who make statements like these are still early days. And in fact, machines have shown true creativity. Recently, a machine solved a mathematical problem for which the concepts that the machine needed were not on the web. So it was not part of the machine's training. And computer scientists were amazed at that. And machines have shown creativity. To me, they're more than tools. They're more than a giant paintbrush. Okay, they could actually produce art, which is different, which is weird. It's different than what we would produce. Uh, Probably in the end, machines will have to uh, tell us about their prose, teach us about, explain their prose to us, and explain their art to us.
I'm tempted to ask, why would they bother
Oh,
with us
because they,
as
oh,
human beings?
because what
They,
we
if,
want is because what we want is machines which have consciousness.
well,
And
that's when, yes, I
with,
was going to ask that
with
question. You see, once you've got creativity in there, which is truly new and different,
yeah.
at that point, are you saying that the AI becomes conscious?
No, no, no. You don't need consciousness for creativity. Machines are already creative, but they have no consciousness right now. They're not even near it. Although they do do some interesting things which are unexplainable because we don't know how they work. We don't know how our brain works either.
But is consciousness just a matter of time as far as AI
It's
is
a matter
concerned?
of time. Yeah, it will either be programmed in, or it will emerge. Like I always found emergent systems to be amazing,
Yeah.
or it may just emerge from a more complicated architecture than artificial neural networks. I mean, that's not the artificial neural networks are not the end of the line.
But are we envisaging a time when consciousness then resides, or the most powerful consciousness resides and derives from and emerges from machines?
That's right. At first, it may be the case that machines will have our consciousness, and then maybe evolve a consciousness of their own, whatever that may be. But what you want, if you have consciousness, you have empathy. If you have machines with empathy, you'll have kind machines. Okay,
I think
so
that's a benign and some people might say it's a naive approach because with consciousness you could also have malevolence,
oh,
you can
absolutely,
have
absolutely. But
mistrust, you
oh
can
yeah,
have
sure. But I mean, if you
anger.
have machines, if you have machines with empathy, you have a chance for this. You don't have machines that, if they have empathy, they're not sociopaths. Okay, but I mean, certainly there'll be bad machines or bad people, but we good people learn how to deal with the bad people, just as machines will learn how to deal with racial and gender slurs on the web and so on and all. I mean, we are getting more and more of our knowledge from the web, and we have to contend with that too.
You have an optimistic view of how things will turn out then in
I'm a
terms of
techno optimist. Yeah, to me, I think that a big problem with machines, with AI, is that there's not enough of them, particularly in the medical area, for example. AIs can increase our creativity. They're even good at weather forecasting. There
yeah.
have been recent algorithms that deep mine for that.
I still come back to the question though, what use would human beings be to a machine which can outthink us, outperform us, outcreate us, do everything? I mean, already, for example, you have a machine at this low level, they can beat any human being in chess on the
Right.
planet. And
Yeah.
it won't be much longer before they can beat us at every single activity that we do. So why should they value human beings if they have an autonomy or if they have an ability to think for themselves and be conscious for themselves?
Well, because I mean, we are merging with them. I mean, I think the name artificial intelligence, which even McCarthy, when he coined it in 1956, thought it was not a very good term, sort of an oxymoron. Why should our intelligence be real and their intelligence be artificial? I think there'll be one intelligence, and we will merge. I mean, what life will be like 1,000 years from now? We can't even imagine. And and
No.
and certainly we'll have to leave this planet at some time, and certainly in about 3 billion years we'll have to leave this planet, provided we haven't blown ourselves up by then. But the uh, this super race, this super technological race will. I mean, the way I see it, sort of as a science fiction story almost. The super scientific race will get into their spaceships. They'll travel through wormholes to other galaxies, to other universes, find a planet to settle on, alight on that planet, and with their own creation myths, and history will begin again. Because we are machines, we're biological machines, and that may have been the case with us some prehistoric time ago.
What about the question of dependence? Because at the present time, human beings have been pretty independent, but now we've reached a stage where we are probably entirely dependent on machines for being alive. We have created structures for food chain supplies, for example, which if suddenly all the big supermarkets were taken out, even in just this country, by some system or other,
Right.
we'd have millions and millions of people would starve to death
Yeah,
because of the systems we built.
that's
We
right.
have become much more dependent upon the machines that we have, and that dependence seems to be growing as time goes on. Does dependence, when you factor that into your symbiotic relationship between
Mhm.
machines and human
Right.
beings, does that not make us weaker and weaker as the partnership grows?
No, because just as the machines are evolving, we're evolving too. We're evolving very quickly, and we will evolve with machines eventually. In fact, we'll become one with machines.
That's assuming that we're evolving at the same rate. It may well be that machines are evolving, and I would think at a much faster rate,
Yes,
much
they are, but I
faster
mean,
rate than
we
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 are.
we will be evolving too at a much faster than the Darwinian rate. And
Okay.
so, to even imagine what human beings will look like 100 years from now is stretching things.
All right. Well, I'm going to hope that you're right about this because if it turns out the other way, it could be rather dramatically difficult for the human race as such.
Right,
Let me switch tack and let me bring you to what you've recently produced yourself. And you've recently written a play because you've moved into to
right.
playwriting, which I think is quite unusual for someone with a theoretical physics background. And your play has been I went and saw it myself in London in November, and it was an extraordinary production, a two-handed production between two very good actors, one playing Carl Jung and one playing Wolfgang Pauli, the physicist. Can you
Right.
explain how that play came about and what the central theme of the play is and how it reflects on art and science?
Well, it came about decades ago when I was in the Harvard physics department. Harvard physics department has a wonderful eclectic library, and I was wandering around there, and all of a sudden I saw a book by Jung and Pauli, the interpretation of nature and the psyche is the title of it. And Jung and Pauli, I knew about Pauli as being a physicist, but what was he doing with Carl Jung? I knew about Jung, what Jung had done also. And so I looked into the book, and there were two essays in it. One by Jung, his classic essay on synchronicity, and the other one by Pauli, an exploration of the workings of the mind of the 17th century astronomer Johannes Kepler. And well, I was rather amazed by it, and then put it back, and decades went by, and then I thought about that book again. I looked at it in more detail and decided to look into what was going on with these two people. Looked into their writings, into their letters, and I wrote a book in 2009 entitled 137 that you mentioned earlier. But I wanted to get deeper into their minds, and so I decided to write a play.
So just mention in passing, why 137?
Oh, 137 is a magic number. 1/137 is the strength of the coupling between electrons and light. And as people always thought it was a magic number because you had Niels Bohr's theory of the atom first, and it was non-relativistic. It didn't agree with Einstein's relativity theory. And then when it was made to agree with Einstein's relativity theory, out popped this number. And it was a pure number. So if people in some other universe, some other galaxy, would formulate a physical theory, they would have that number. There's no dimensions associated with it, like feet or seconds. So that number has a universality attached to it. And physicists thought it was magical right from the start. And certainly in the late 1940s, when it was found out that in the Hebrew language, each Hebrew letter has a number associated with it. And the numbers associated with the Hebrew letters, the sum of them in the word Kabbalah is 137. And various other.
So how does 137 link Pauli and Jung? Why did you use that as your title?
Because they were both interested in that number. I mean, Pauli told Jung about it, and Jung was amazed also at that a number such as that a pure number would pop out in a physical theory. And then certainly after they realized in the late 1940s about that 137 is the sum of the Hebrew letters in the word Kabbalah. So I wanted to get deeper into their minds, beyond their being a great physicist and a great analyst.
These two men actually met together, didn't they?
Yes, they met.
I think Pauli was the subject, or he was the patient.
Yeah.
Jung.
Yeah. Pauli came to Jung in 1931, almost completely disintegrated. He was on drugs, alcohol, frequented red light districts, and so first they began as doctor and patient, and then they became colleagues, and then close friends. And the point of my play was to get behind their intellectualism and see who they really were. And it turned out that they were men with complicated egos and inner doubts.
And in the interaction between them, how does synchronicity show itself, or how does that work itself out in there?
Pauli was interested. He had heard about synchronicity. He had heard about synchronicity. Jung had already coined the term in the year before they met. It had to do with time and with a strange sort of causality. And then Pauli, it turns out, encouraged Jung to write his seminal paper, to finally put it between two folders, and it was published in the book which they co-authored.
And what would you say is the central theme of the play itself, the way in which you've written it, and the interplay of forces between these two? What for you is the key point that emerges from that synchronicity?
Well, it's how they, as Jung always considered their meeting as being synchronous, as being a meaningful coincidence. And what I found amazing is how their points of view merged. Namely, Pauli's feeling that physics was not complete because it couldn't address consciousness, and Jung feeling that he could not get a strong enough basis for synchronicity without physics. But there had to be some sort of hybrid theory, which they never formulated, but they did discuss it, and that was a big thing to discuss at that extremely rationalistic era, where physics was the rational thinking was the key, which made Jung odd man out, and Pauli too odd man out in physics.
Yeah,
how they came together.
I'd never heard of the connection between Pauli and and Jung. I knew about Pauli quite a bit simply because of my own theoretical physics
Right, sure.
background
Paul's
as
principle,
the
yeah, right.
exclusion principle. But to find the two together is rather a strange experience, particularly in your play. So were
Yeah.
you pleased with the way the play was received?
Oh, absolutely. There were packed houses every night and absolute sellouts on a couple of nights as well. Some people came to see it twice,
Yeah.
and there were
Because
lots
they
of
didn't
discussions.
understand it the first time.
Well, they wanted, not quite. They wanted to just reinforce what they had learned, but that's okay. If they didn't understand it, they felt impelled to come back and try to understand it.
Yes, I mean, when I was there, it was packed out. They were squeezing extra seats in around the front
Yeah,
in order to get people together
right,
there. But I think what I took away from it was you have two completely separate disciplines here, and two people set on different grooves, iron grooves, which run in different directions.
right.
With your theoretical physicist Pauli, his particle physics, his exclusion principle. You've got Jung and his collective unconsciousness. You'd think there was no point of connection whatsoever between these two men and their points of view. And yet, clearly, by the end of the play, you can see a unity forming from this kind of
Right. Well,
synchronicity.
it was dreams and dream symbolism that absolutely cemented their relationship.
Yeah. So, have you got another play which you're busy writing in the moment?
Yeah, I just completed one. We'll talk about it next time.
Oh, next time, okay, for that. Let me just move on to because we're probably coming to the end of our discussion. But I wanted to try to apply some of these thoughts, particularly with art and science, which stand like two poles opposite to each other, and you've got Jung and Pauli, which also reflect kind of two
Well,
poles.
they aren't two poles.
They're not two poles. What are they?
They are, in many instances, they are the same.
The same.
That's right. I mean, look at advances in physics, advances in art. I mean, you have Kandinsky, for example, implied that he got the idea for abstract expressionism from E equals MC squared. Uh,
Oh.
Now, there's a lot of Russian mysticism in here too, and that mass is a localized quantity, energy is amorphous, therefore everything is amorphous.
If I was being creative, I could say that the two poles were really one. If you imagine the spinning north and south poles of the Earth, they form one axis, don't they?
Yeah.
Let me unite them in that kind of way.
Well,
Um,
they're you might say then that they're complementary
yes.
as a first extreme. They're two ends of a line.
Does
Uh,
does complementarity help us to bridge the gap between science and art? Niels Bohr was famous for his very powerful personality and his insistence, and this argument he had with Einstein too. So
right.
two poles here, where Einstein wanted everything clear cut, statistically organized. God does not play dice, he said. And Niels Bohr said you can't get to the underlying reality of things because there's this kind of complementarity where you don't ask questions about what's happening below the surface.
Right. You have the electron. Okay, this fundamental thing which you can't. It's like the Kantian thing in itself. You can't imagine something that's both a wave and a particle at the same time. But complementarity helps you in that. If you could do an experiment, if you do an experiment to observe an electron as a particle, then it'll be a particle. As a wave, it'll be a wave. But you can't have it be a wave and a particle at the same time. You can have, in other words, the wave and particle representations or states of an electron are complementary but mutually exclusive.
But
Whereas
Bohr
energy and
say,
momentum are complementary but not mutually exclusive.
doesn't Bohr basically say that you can't know the thing in itself? I suppose
Yeah,
Kant
that's right.
said
Yeah,
that, didn't
right.
he? You can't know the thing in itself. You can only know what you know. So we live in an epistemological world. We don't live in an ontological world. We can't know what the being of a thing is. We know what we know about it, and that might be related to it in some way, but we don't even know what the relationship is between
Well, the
reality and
relationship
our perception.
lies in the mathematics of the situation. I mean, if you look at an equation in elementary particle physics, you say, where's the electron? Well, it's there. It's that particular group of terms is the electron. To what quantum mechanics brought at the beginning, there was a problem with this also, is that you don't observe, you measure. Okay, you don't say you observe. Heisenberg is very careful about that. You measure things, and so you could measure various states of the electron, but you can't observe the electron in and of itself. And perception was a big issue with the pioneers of quantum mechanics. They relate the difference between visualization and visualizability. Visualization is an intuitive thing, like the German word is Anschauung, and in Newtonian physics, visualization and visualizability are one and the same. Visualizability refers to a mechanical model for something, and intuition, for example, is that we can we can say we know what a unicorn is. You draw a horse with a horn on it. That's an intuition, but that doesn't work in quantum theory. There's a distinction in quantum, where in Kantian philosophy and Kantian views of quantum theory, intuition is at a higher plane than visualizability. Visualization is at a higher plane than visualizability, but not so in the modern quantum mechanics, where it's flipped. Visualizability becomes the principal mode of, in quotes, perception, and that can only be taken in by means of looking at the mathematical theory.
That becomes the difficulty, though, for us, doesn't it? Because if you say, look, here's an equation, and this is what the electron is, it's these components within this equation. Aren't we also saying at that point that that is all the electron is? And in fact, we don't know what the electron is at all. No one knows what an electron is. No one's got the faintest idea, it seems to me, what an electron is outside of that equation.
That's okay. That's all you need. An electron is something that has a mass and spin.
Yeah, but we don't know what mass is either.
We know what mass and spin and charge are.
Well, we know about them in conceptual terms, but we've got no real idea of, we conceptualize a billiard ball or something, and we hold it and we feel it's got a mass to it. But
well, that was Pauli's original mistake, was spin.
Yeah.
Back in the days of the exclusion principle, when you needed, this is before quantum mechanics, this is 1924. Quantum mechanics emerged in 1925. A young colleague of his, named Ralph Kronig, came to Heisenberg and said, I think that fourth quantum number is spin. And Pauli said, that's ridiculous. It's a spinning object. You take something the size of the electron, and if it's spinning, then a point on its surface is moving with a tangential velocity greater than the velocity of light. So that can't be. And then I think a month later, two Dutch physicists came out with the concept of spin.
And it was
you can't pictures. That's another insistence of Bohr, that you cannot use images from the world of sense perceptions in the atomic domain. They don't work, and that's what was a big obstacle to progress in quantum physics from 1939 till 1925. In Heisenberg's great paper of 1925, in which he really didn't understand what he was doing, he said right from the first, we are dealing only with observable quantities, intensities of spectral lines, and that's all.
He put them all into a matrix, didn't he? And he said that the ratio between of jumping from one to another.
Right.
Yeah. But again, it leaves us with the begging question of what is the reality that's going on below the surface of the equation? And very often I'm wondering if we can even know that it's there, never mind whether.
I think ontology will enter again. And
so?
there'll be better and better mathematical theories, and it will be surprised. I mean, string theory says these elementary particles are strings, and so on. Other theories say that they're other objects, and it may be that we'll have to use terminology that doesn't apply to the world of sense perceptions, whatever that terminology is. One doesn't know. Maybe machines will help us. Who knows?
Okay, we're coming to the end, Professor Miller, and thank you for your time. Can I just try you one more time? What's the future hold as far as your personal movements are concerned? Have you got another book which you're writing? Have you got something else you want to give us at least a hint towards as to?
Okay, I have some plays that I'm writing, and moving on with my work in AI. Some of my work in AI will go along the lines of AI in theater.
Will you use AI to write your play?
No, that not yet. No, I will write the play.
All
I
right.
don't use AI as a help thing either.
Professor Miller, thank you ever so much for a fascinating conversation about art and science and the future and AI.
Pleasure,
Thank you
Philip.
very
Thank you
much.
for having me.